Welcome to section 5.2, Growth and Decay of Rational Exponents. Your homework tonight is page 178, 1 through 47 odd. First, we want to look at the definition of rational exponents. When you look at this definition, you want to think about the fact that p divided by q is really the power over the root. So when we look at the 8 raised to the 2/3 power, we can think of that as the cubed root of 8 squared. I would suggest making sure you do the cubed root of 8 first before you square it. So our cubed root of 8 is just 2, and 2 squared is going to give you 4. Now looking at our second example, B, you can look at 9/16 raised to the 1/2 power. The quick way I always think about this is it's the square root of 9 over the square root of 16, because that 2 right there is telling you you're going to take the square root of 9 over the square root of 16. The square root of 9 is just 3, and the square root of 16 is 4. So your answer is 3/4. Example 2 says to write each expression using positive rational exponents. So the first thing I would do is go through and take the 27, a to the negative first, b squared, and raise it to the power over the root. So you have 4/6. Now, it might be quite easy to just erase that 4/6. And 4/6 reduces to what? 2/3. So then take the 2/3 and distribute it to each of the powers inside. So that will give you 27 to the 2/3, a to the negative 1 times 2/3, and then you have b squared to the 2/3 power. Giving us a little bit more room, sorry. 27 to the 2/3, the cubed root of 27 is 3, and 3 squared is 9. A to the negative 1 raised to the 2/3, when it's raised to a power, remember you're multiplying your powers. So that becomes a to the negative 2/3. The b becomes b to the 4/3. So if I want to write this without negative exponents, I'm going to write 9 b to the 4/3 over a to the 2/3, and then I'm done. Now our next example, we're going to first change these into powers. So that means I have x to the 1/3 times x to the 1/6 divided by x to the 1/5. You could put them as a fraction, or you can remember your rules, where this is x, and if they're multiplying, they're adding, and when they divide, they subtract. So now you just get a common denominator, which I'm going to put all over 30. That's going to be times 10, so that'll be 10 minus 5, or plus 5, minus 6. So that gives you 9/30, which gives you the final answer of 3/10. So x to the 3/10. Example 3 tells us to simplify. When you see something outside multiplying something inside, you're going to think you need to distribute. So to take this and distribute, I'm going to have 3x to the negative 1/3 times x to the 1/3 minus 3x to the negative 1/3 times 4x to the 4/3. So giving us a little bit more space. So going through, you'll have 3. You're going to add negative 1/3 plus 1/3, which gives us 0. And then 3 times 4 is 12. Negative 1/3 plus 4/3 is 3/3. So that just gives us 3 minus 12x, and that's your final answer. Our first one tells us to simplify. You want to look at it as two different problems. So you're going to simplify this over this minus this over this. So if we look at the blue one first, 9 over 12 gives us 3/4. 8 to the 1/2 minus 8 to the first is going to give us 8 to the 1/2 on the bottom. B to the negative 1/2 over b to the negative 3/2, you're going to subtract negative 1/2 minus negative 3/2, so you just get b to the 2/2, which is b to the first on the top. Then you have minus 6 over 12 is going to give us 2 on the bottom. A squared over a gives us a on the top. B to the 1/2 over b to the negative 3/2, that's going to be 1/2 minus negative 3/2. So that is going to become 4/2, which is going to be b squared. So that will leave you with b squared on the top. And then this is going to be your final answer. Yes. Now we're going to go to the problems where we're trying to isolate for the x. First, you want to just divide by 6. Then you get x to the 3/2 is equal to 8. Now, I want to be able to get x to the first power. What you have to remember is, how do you get 3/2 times what will give you 1? Well, if you think about it, you just need the reciprocal of 2/3. So that's what we're going to do. We're going to raise each side, I should say, to the 2/3 power. So I'm going to raise that to the 2/3 and that to the 2/3. Then this just becomes x. And 8 to the 2/3, the cubed root of 8 is 2, and 2 squared gives me 4. So my x is 4. On example B, the x value is inside the power, so we need to have the same bases. And then I can set the powers equal to each other. So you're going to keep the 2 to the 3x, and 32 is 2 to the what? It's 2 to the 5th power. Once your bases are the same, then you can just set your powers equal to each other. So you'll come down and say 3x equals 5, divide by 3, and x is 5/3. And then you're done. Okay, so we've got a couple more. If you notice, the x again is in the power. So we want to make sure we get to the same base. 3 is already pretty basic there, so we're going to make 27 into 3 squared, or 3 cubed, I should say. And that's 3 cubed to the x minus 4th power is equals to 3 to the x plus 2. So that will give me, remember when you raise to a power you're multiplying, so that gives me 3 to the 3x minus 12 is equal to 3 to the x plus 2. Then you want to go through, since you raised it to the same base, you can set these equal to each other. So 3x minus 12 is going to equal x plus 2. You're going to move the x around, gives me 2x. Move the 12 to the other side, gives me 14. And then x will be 7. You're more than welcome to always just check and plug it into the original equation to see if you're right. Now our next x is not in a power, so we're just going to try to isolate as much as we can. We are going to divide both sides by 3. So we have x minus 1 to the negative 2 power is equal to 4. So the reciprocal of negative 2 is negative 1/2. So we're going to raise both sides to the negative 1/2 to keep that property of equality. And then I'm going to get x minus 1. Negative 2 times negative 1/2 is 1, so therefore I did my job. And then 4 to the negative 1/2 power is really, if you think about it, it's going to be 1/4 to the 1/2, which equals 1/2. Right, because the square root of 4 is 2. Then you're going to add 1, so x is equal to 1 and 1/2. and you're all done. So this is our last example, and you want to go back to your stuff from 5.1 to really think about this. The value of a savings bond increases at an annual rate of 4%. So I'm going to use the equation A of t is A0 times 1 plus r to the t power. Our r is going to be that. It says if the bond is now worth 500, find its approximate value 3 years and 4 years from now, 4 months from now. So this is where we're going to start with. So I'm just going to call that A0. So then I have the equation A of t is 500 times, this becomes 0.04. So that's 1.04 to the t power. Now, 3 years from now is just A of 3. So it's 500 times 1.04 to the third. And A of 3, you should get on your calculator $562.43. And that would be your final answer. Now, if you're thinking about 4 months from now, 4 months from now, you really have to convert into years. So that is 1/3 of a year. So you're going to do A of 1/3 is equal to 500 times 1.04 to the 1/3 power. And when you get that answer, you would expect that you're going to get something less than the 562, I hope. You're going to get $506.58. So if you have any questions on any of this, please feel free. Come after school. I'll be after on Wednesday. Ask me questions.